question number 1. We have two open ends, which means that we absolutely must have an antinode at each end. You don't have to, but I always like to draw a standing wave with its reflected wave because it allows me to see where the antinodes are. They're the maximum displacement points. So this is the least amount of antinodes I can fit into my tube, which means that it is the first harmonic. And fundamental frequency is the same way of saying first harmonic. So this has 2 antinodes and 1 node. I know that the distance here between these two is 0.8 meters. And so in order to find the wavelength, you take your distance divided by the number of waves. So this, from crest to trough, this is a crest to trough, is half of a wave. Because if I were to get a full wave, I would have to go from crest to crest, right? Or trough to trough. Or have that S wave of equilibrium, up, down, back to equilibrium. And this is only half of that, crest to trough. So then the equation that, was it, Mia? Was this yours? Okay, so the equation that Sam did was distance divided by waves. Or you can use the distance for this one times 2, because obviously half of a wave multiplied by 2, you get 1 full wave. And what should I include here that's missing? Meters. You don't want to miss your units. That's always minus a half, at least. Okay, the wave speed equation. Now, just in case you get this problem wrong, I always encourage you to include the equation, which is in your physics helper. It's frequency times wavelength. Your wavelength is 1.6. Your frequency is given. That's your 202. And you end up with 323.2 what? It is, this one's velocity. What's my unit for velocity here?
Meters per second.
Don't forget your meters per second for speed. Okay, now that we're getting into the next harmonic, I wanted you to find patterns. Once you get your fundamental frequency, 2 open ends means that it should be antinodes. If I had 2 there, I should have 3 here, right? 1, 2, and 3. It increases by 1 each time, the number of nodes and antinodes. And let me just draw the reflected wave so you can see where the nodes and antinodes are. So this is your second harmonic. The third harmonic would end up with 1, 2, 3, 4 antinodes, so on and so forth. So that's a pattern I'm going to add here. As harmonic increases, one thing you want to know is node and antinode increase by 1. Now, there's 2 ways to do this. And Colin did it by the fact that frequencies and harmonics are always multiples of the fundamental frequency. So if our fundamental frequency is 202 hertz, if I double the 202 hertz, I get 404 hertz. Colin also used the fact that the wavelength is decreasing, and because wavelength and frequency are inversely proportional, if the wavelength doubles, if the wavelength here is decreasing by a half, then the frequency has to increase by 2, based on the fact that they're inversely proportional. Now, there's another way to do this problem. It is the fact that the speed that you got from the first harmonic is going to be the same speed you get for the second harmonic. It's going to be 323 123.2, your wavelength, how much of a wave is this second harmonic? I start at a crest, I go down, back up to a crest, so that's one wave. And I know that this distance is 0.8. It's not going to change because remember, the length is the length of the tube. So the length of the tube is never going to change. It's just the number of waves that fit into it. So my wavelength is going to be one full wave in my 0.8 meter tube. And then you're going to use your equation, V equals frequency times lambda. Your velocity is 323.2, and your frequency is what you're solving for. If I divide my distance of 0.8 to both sides, I'm going to get exactly 404 hertz. Same calculation that Colin got when he just doubled the fundamental frequency. So you can go by patterns, or you can go by calculation, but the calculation requires you to understand the fact that the wave speed doesn't change. Any questions? All right, we already went over this, but I'm going to emphasize it anyway. As the harmonic increases, what happens to the wavelength? What happens to the wavelength? It decreases. And based on this inequality, if the wavelength decreases, what happens to the frequency? Increases. Increases. And then this is a concept that I want you to understand. My musicians already know this. As my frequency increases, what happens to my pitch? Also increases. Questions? All right, I chose to do the whirly tube, which is an example of two open ends. When we did the Speed of Sound lab, that was an example of one open end. And then the last example we have is of two fixed ends. In this lab, not the Speed of Sound, the harmonics lab, the patterns, I gave you examples at the bottom of what two open ends, two fixed ends, and what one open end looks like. So obviously, your quiz is not going to be the two open end example, otherwise it wouldn't have used it as your warm-up. It's going to be one of the other two. But you need to understand, well, what type of situation is this item that I'm trying to get quizzed on? Is it a two fixed end, a one open end, or a two open end, and then go from there. Any questions? Okay.